Hello, and this is now initial config 4. So we've secured our firewall to a greater or lesser extent. We've created the security rules. We've got our networks. We've got everything in place now for the firewall to control the traffic going through it, as well as be managed. We've got our security profiles in place so that we've got our security, our next gen security working as well. And so now what we're going to do is we're just going to use this. Imagine this is a small branch or something like that. We're going to use a DHCP server on the firewall to give our hosts an IP address. You can also use DHCP relay. So if you're going to use DHCP relay, that's where you're going to be passing on to another DHCP server, and then you have the obvious settings. So you've got the interface and the DHCP server IP address, and then that would deal with that way. But we're going to do the DHCP locally on the firewall for now. Okay, and then we're going to be using this box here to do the testing. This is now behind our ETH12 interface, and we're going to use this to get our IP address. Okay, so let's configure the DHCP server. So the interface we're going to put it on is ETH12. That's our internal interface. We have a mode as well, enabled or disabled, and that's based on the detection of a DHCP server on the same segment. So you can either enable it and force it to be on, or auto, and where it's supposed to look for another DHCP server, and if it finds one, it won't offer addresses. Okay, so going further down, we're going to ping the IP when allocating a new IP. I always select this anyway. It isn't completely fail-safe, because you've got to bear in mind that some devices don't respond to IP ping, so they won't respond, but in most cases they will do. So this will stop you getting those duplicate addresses, in theory. The lease, unlimited, or timeout, so you can set a timeout. Most people would set a timeout for a day. That means you've just got plenty of time, plenty of IP addresses, for it to renew. If it's unlimited, potentially you would end up at some point, if you had enough people going through the environment, you would end up with exhausting your DHCP range. So IP pools. So we can create just a single, as with Cisco. So we can do 192.168, say in our case 50.1, and then we've got comma and then .2, so we can do that type of thing. We can do a subnet, so /24, or we can do a range of IP addresses, so from this IP address to that IP address. I did discover earlier on, oddly, and I'm not quite sure why, but it did actually hand out its own address when just using a subnet. So, but then you could also reserve the addresses. You could reserve 10 addresses. So if we go for, in fact, let's do it that way. So we're going to do 192.168.50.0/24. I'll do this a little bit on the fly now. So we're going to reserve the address 50.1, and we're going to reserve D.2. And we're going to reserve those addresses just to give us those two addresses that we can use later. So we'll just call that the gateway, and then just reserved. Okay. And on our options tab, the inheritance source I'll show you quickly in a second. We have custom DHCP options as well, so you can add your option codes to it that should you need to, or you can do inherited. But basically what we're going to be looking for is adding our gateway, our subnet mask, our primary DNS, and our secondary DNS. And then if we wanted to add Win servers or primary servers or the NTP or so on, give it our DNS suffix. Okay, and then that is configured. Now, just really quickly, just to go through that, because I did say inheritance source. So if we were to have an interface on here And we'll just pick any random interface. So we'll pick Ethernet 1.4. Okay, it's currently a tap interface. They're always tapped by default. So we're going to go with layer 3. I'm going to give it a virtual router. Going to give it a security zone, which is outside. And then we're going to make it a DHCP client. Okay, so once we made it a DHCP client, we can just click OK on that. Okay, and then if we go back to our DHCP server and open it back up, you'll be able to see that now what we'll be able to do is go to options. So we've got an inheritance source, so we can select the inheritance source, which is our ETH1.4. We can check the inheritance source status from it, so we can actually check the status of that interface, and at the minute it's got nothing because it's not configured. However, moving further down, then we can go with, if we had DNS servers or NTP servers that were passed to us through that DHCP that we had on ETH1.4, so that's DHCP from an upstream device, we could put that in here, inherited in here, and then that would inherit the DNS settings from that device. Okay, but we're going to do that now. And then we're going to commit this, because that's all the configuration that's needed. Okay, so now that's committed successfully. So if we pop back over to our desktop, renew it, we get 192.168.50.10. Our default gateway is 50.1, and we've got our subnet mask. And we've got our DNS suffix of mode 44.local. Going back to our firewall, we can view the allocation. And if we decided, just as a side note, if we decided then at some point that what we wanted to do is we wanted to make sure that this device always had this this IP address, what we could do is we could create a reservation 192.168.50.10, create a MAC address, paste that MAC address in there, call it desktop, and then click OK. And now whenever that MAC address is presented, it will get that IP address. You can also see under here as well, on the allocation, this gives you an idea of how many IPs we've got, the amount of IPs allocated already, and the usage of the DHCP pool. If we wanted to further secure this, we could put a DNS proxy in. So at the minute we're using 8.8.8.8 and 1.1.1.1. Okay, so let's just say we wanted to create our own DNS proxy. So that way, all of our devices are going to use the firewall as a proxy to get to DNS. So they will go to the firewall for DNS, and the firewall will go out, and it'll be a caching DNS server basically. So what we want to do is we want to create our, so let's say we want to go to 1.1.1. We've got no secondary, and we're going to go OK, like that. Right, so now we've created that DNS proxy. That's going to go to 1.1.1.1. And then if we come back to our DHCP, and come into here, options, and then we just simply remove this one, and then .1, and then that will give us our DNS that we're going to use. So now we're going to use the firewall as a DNS server. Now this is really sort of for small branches and things like that, somewhere we haven't got a lot of infrastructure necessarily, but you want to get the most out of your firewall. So this now means that all our users are going to go to our firewall for DNS, which means that we control where that external DNS is. It also gives us the opportunity to insert certain things. So we can create a DNS proxy rule as well. So we can always look for, so if we're going to a certain domain name, we can use these DNS resolvers for that, and then turn on caching of domains resolved bias mapping. We can create static entries, so we can create our own entries, so we can start to use FQDNs, and then we can make an address, so we can then go to there, and then we have advanced settings as well for the UDP queries retries and TCP retries and so on. So basically it gives you the opportunity to have your own DNS server sort of within your office environment or your home environment, and I use it specifically, I have it say for Global Protect for the internal host detection, because on mode 44.local, obviously that can't be resolved on the internet, so I use that, and then I have my Global Protect knows it's on an internal network because it can do a reverse lookup against it. Okay, so we have selected that. We've changed the options on the DHCP. So now our DNS is going to be 50.1, so we're going to commit that. Alright, so now that's committed, so we just close that, pop over to the desktop, see if we can do a renew. Which of course, obviously I've done that wrong, so I need to do a ipconfig all. Okay, so now we've got the DNS servers, which is 192.168.50.1 as we set in our DHCP scope. We've still got the mode 44.local, and we've got our IP address that we wanted, our .10. That's really the setting up the DHCP server. Just pop back. There was just something else I wanted to quickly talk about. So with URL filtering, one of the things that often gets overlooked is certain protocols, and QUIC is definitely one of them, and I can't stress this enough. So when using URL filtering, once you've created your DNS request, so basically with QUIC it sets up the whole thing in a single socket. So the GET request actually goes across QUIC encryption, which is proprietary encryption, and Palo Alto can't decode it. Now I've got a video coming up soon about DNS over HTTPS, or DO as it's called. And decrypting that and the stuff you can do with that, and that's very interesting as well. I've also got one coming up about the post-quantum computing VPNs and so on. So it's just best practice as far as I'm concerned. I always do it. I pretty much do it everywhere I go. Is we're going to create a block QUIC rule, and then this is for URL filtering purposes. So basically now we get the DNS request, and then the GET request goes across in a separate connection. So the URL filtering, even if it's not being decrypted, that traffic is not being decrypted, the URL filtering is more likely to be able to see it. So we're going to create that again from our LAN zone. It's going to go to destination, which is going to be outside. And the application for that is going to be QUIC. These drop down always bugs me because it always depends on how quickly the firewall's running. So QUIC. Okay, and it's found it. And then we are going to deny that. So if we deny that, what's going to happen there, in my way of looking at things, is we deny it, do application any. We deny it, that sends back a notification to the browser. The browser then downgrades what it's doing and just goes through a normal DNS lookup and doesn't create that tunnel. Again, no profiles. Again, anecdotally, there are some people that say that the profiles still get evaluated on a deny rule. Apparently they don't, but I always like to leave them off anyway, because you're not going to need them. Anything deny there, if you imagine a deny is literally... if we look at our rules, so we've got all our rules here, which is all our standard stuff that we expect to see, and then assuming that this is allow, it then moves on to profiles. Where it's a deny, you'd imagine it's not going to move on to the profiles, which it doesn't, because there's no traffic to evaluate. Okay, it's no use at the bottom there, so we can move it. We can move to the... Sorry, I had to reload the browser there for some reason. So we can move that then to the top, which it'll do for me now, I'm hoping. Seems to be a bit funny there. Okay, so that's now at the top and it's renumbered everything. And just a quick thing as you go through the firewall, this can also be dragged, so you can click it and then drag it to where you want it. You can move it to the bottom or move it down or up by a different rule. You can clone it. Also as well, if you're ever in the situation where you need to select certain things. So for instance, I've left out LAN subnet here. So we know the LAN subnet is going to be our 192.168.50.04. Well, I've left it out there, but that isn't actually best practice, is it? Because that's what we said previously, was that we don't want anything left sort of ambiguous. We want to you need to have as many configurations within a security policy as you possibly can. The more configurations you have, the more you know it's logged down. So if we wanted to just quickly do this, we can move LAN subnet up to there, DMZ subnet up to there. That creates that, and then DMZ zone. And now we have the only traffic that we can possibly see, which is going to be these going out. It's less of a thing here because it's a denier, but it's a good practice to get into. And we could create a tag and so on if we wanted to view it. But that now is going to mean that we block QUIC at the perimeter. So we're going to have to drop down and gives the firewall more chance to look at stuff. Again, something else to remember, and I can't say it enough, something else to remember is all these security features that are on the firewall are absolutely fantastic. I love Palo Alto firewalls, but you have to help the firewall. It has to be able to see that traffic. So decryption is a real must. It's a real necessity to get the best out of your profiles, but they do work. They do work and they do make guesses outside of that. I think the biggest side effect of that is an increased false positive. Okay, so that's it for this video. I'm gonna commit that just because I'm here. So that's it for this video. That is the initial config 4. So now we've blocked QUIC. We've got DHCP being set out. We know how to create our own DNS. We've got DNS Proxy as well. Sorry, we've got DNS Proxy. It's also, we're controlling the DNS that our users get, and we can add our own DNS entries, and we can create different rules for different domains. And we've also got our connection specific to DNS suffix. That's configured as well. So you're all good to go. So I'll see you in the next